Hello and welcome to Func Prog Sweden 11, last one of this year. And today, as it's the last one, we will have almost like a bonanza. 4 presentations, so welcome everyone. I'll head straight over to the agenda for tonight. First, short introduction by me. Then, how Griffin uses TAP and Portal to understand and debug their event-driven architecture by James. Then a sweet beginner's guide to Scala by Daniel. And then we head over to reduce system complexity with data-oriented programming by Jonathan. And last but not least, this is not a monad tutorial by John. But before we begin, I would like to thank Adabeat for the kindness of the video sponsorship this year. Adabeat is an IT consultancy company based in Stockholm with office in Ho Chi Minh in Vietnam also. If you want to know more about Adabeat, check them out on adabeat.com or in social media. Also, I want to push a bit for the coming schedule next year. Second week of January, we'll run a meetup from Vietnam, because I will be in Vietnam. Then 17th of January, we're back here in Stockholm and running another meetup. And then we'll have meetups in February, March, and onwards. If you want to support the community, of course you want to support the community, you should join the meetup community over at Meetup, the Func Prog Sweden community, of course. You should follow our channel on YouTube. And if you really like functional programming, you should get a t-shirt like I'm wearing, and you can get it at funcprogsweden.myspreadshop.net. It's the perfect gift for your partner for Christmas, we all know. Try it out. If you have any questions during the presentation, please use the YouTube chat, and I'll read it up for the presenters. With that said, let's start. First presentation. Welcome, James. I'll do a short introduction of you, James, and I'll hand you the cable.
Thank you.
So, let's see if James, a technology leader with 2 decades of experience, building digital products and high-performing teams. He started his career as a software developer, but had an early interest for people, process, and psychology, pulled him towards leadership. Welcome, James.
Thank you so much, Magnus.
You're very welcome. So you actually been a software developer, and now you're going to present.
That's right.
I'm just joking with you, sorry. Sorry. Yes, your presentation. Welcome, James.
Thank you. And thank you for inviting me back. It's an honor to be back here.
Yeah, you're very appreciated.
Hi, everyone. Today I'm going to be talking about how Griffin taps into one of Clojure's superpowers. So first, I'll introduce myself. My name is James. I'm the VP of Engineering at Griffin. I've been doing that job for almost 2 years now. And my background is in technology leadership. I've been doing that for a while before I was a software developer originally. Pretty much my only claim to fame in the Clojure community is that I led the team that invented and published and open sourced a software architecture called Polylith, which is starting to take off a little bit in the Clojure world. So if you haven't checked that out, do take a look at that. Okay, what are we going to be talking about today? So the 2 things in orange are the important, cool ideas, concepts that I want to teach you a bit about or show you. But to get to those, we need to go through some context. So the sort of final destination, the exciting thing, is how we do debugging in this event-driven system that we have using TAP and Portal. So if you're into Clojure, you might have heard of or used those before, so we can show you a little bit about how that looks like in an event-driven world. But to understand that, you really need to understand a bit about the platform and the sandbox that we've built. And then to understand the platform, you really need to understand the architecture that we're building that platform on top of. And the cool thing that I want to show you and talk to you about there is transducers. And that's a more sort of general functional programming concept. So even if you're not in the Clojure world, understanding that might be cool. So for Clojure people, there's something, and just for people that are interested in functional program, there's hopefully something. And to understand about the architecture, we need to understand a tiny bit about the business. I promise I'll try and whiz through the non-technical tech stuff and get to the good stuff as quickly as possible. But I think it is important to understand each step along the way. So let's dive in. Griffin, the business, what are we doing? So we're building a banking as a service platform for fintechs to build their financial products on top of. So what that looks like right now, if you're a fintech, is you have to understand this immense financial ecosystem. You either have to choose to build your own parts of these jigsaw pieces, or you have to integrate with existing platforms that tend to have been around for a while. They're not always well documented. Their APIs can be of varying levels of quality, is perhaps a polite way of describing it. So that makes it much slower, much more costly to get to market. If you've got this brilliant idea that you want to test, having to arrange all those jigsaw pieces and figure it out, that's not easy. So our whole strategy is to make that much, much smoother, much, much faster by building a platform that takes away the pain, the complexity of all of that. So that means that if you're a brand, a big brand like Apple, and you want to do embedded finance, or you're a much smaller fintech and you're starting up and you're trying an idea, both of them could come and use our platform and build their idea as quickly as possible, with one of the unique selling points being we're also becoming a bank. So we're applying for a banking license in the UK, which means that if you're a fintech and you need money, we can also lend you the money or help you out with other financial services. So it's sort of a win-win situation. Okay, so from a sort of high level, what does that look like in terms of what's the USP or how we do things differently? So we're the orange box in the middle, so that's Griffin. And what we're doing is we're building on top of an existing financial ecosystem, that's the gray boxes underneath, and then we're offering that service via API first to our customers. So those are the blue boxes, the different types of customers that we work with. So it's all about wrapping that complexity that exists in the financial ecosystem that I was talking about, offering these clear products via a nice API that's well documented, that makes it really easy and fast for our customers to launch their products and get off into the market. Okay, so now that's the business. Let's dive into the architecture. So how have we built this? You'll maybe notice first the Clojure logos everywhere. It's a 100% Clojure shop, so it's Clojure script in the UI, Clojure on the back end, Clojure in the API. So it's Clojure everywhere. That's cool. But let's go through from top to, I guess, the middle to start with. So you've got the customer, they're making requests to our API. As you do to the endpoints, the API is checking, do you have the authorization and the authentication, i.e., are you allowed to make that request? If so, passes it through to the main system proper. And we're using Foundation DB as our event source queue. So what that means is each request gets placed in the queue, and then we have the brains of our architecture we call procs. I'll explain what those are later, but basically you can think of it as the brains. That's where the business logic lives. And each proc is a little process that is listening on the queue for a particular message that it understands. And when it finds a message like that, it says, I know how to process that. So it takes it off the queue, does some processing, and then puts messages back on the queue for other procs to listen to carry on the processing. So essentially, the procs are talking to each other, but they don't know about each other. They're talking via the messages. So that gives you a really nice decoupled architecture that scales really nicely. And they also use FDB for local storage. And then on the other side, when we're connecting with these third parties, so when we're connecting with that financial ecosystem I was talking about, it's basically the mirror opposite. So we're still using FDB for queuing outgoing requests. And then we have a service gateway, which you can think of as a wrapper that essentially hides away the complexity of their APIs from the system and gives you a clean boundary, if you like, a gateway. And then on the way back in, once we get the responses back from the gateway, they get queued up and they come in as though they're requests from the API. So it's basically a perfect mirroring. And then worth mentioning, we have a UI as well as the API. We think that most of our customers will build against the API because they're building their own applications, web, mobile, or whatever. But the UI is there, so we can sort of be the canary in the coal mine and test the API, make sure it makes sense and you can build UI against it. But also for smaller companies that maybe want to get up to speed faster with onboarding their customers or managing their cases using our ready-made UI. So that's the basic architecture. Let me take a quick sip. So I'm a very visual person and I like metaphors. They help me to think about things. So if you're not a visual person, you can just ignore this and think about the previous diagram. But for those of you that like metaphors, so what am I showing here? So we imagine our system as a body, and imagine that the way it interacts with the world is through the senses, like listening or sight. So that's the API to our customers and service gateway to the third-party services that we talk to. So that's how we're getting messages in. And then we have a nervous system which transports those messages up to the brain where we're doing the main processing. So think of the Procs as the brain, Foundation DB as the transport system or your nervous system, and then your senses are the input and output to that. So when I showed this, a similar slide to the last one, about a year ago when I was talking about banking on Clojure, it wasn't Foundation DB. The rest of it looked very similar, but we were using Kafka. So what we essentially did last month was we ripped out the spinal cord and the nervous system of our platform, and we put in a new one, and we did it without the Procs noticing that anything had really changed. So that's a difficult engineering problem, and it's obviously big props to our fantastic engineers. But one of the secrets as to how we were able to do that so smoothly is because Procs are transducers, and this is the first cool functional programming idea that I wanted to share with you. So what does it mean that Procs are transducers? Maybe I'm just explaining one word that you don't know with another word that you don't know, and that's not too useful. So I will try and quickly explain transducers. To be honest, Rich Hickey has done really good explanations of this, and it's taken him like an hour each time, and he's much better at explaining things than I am. So there's a risk you're not going to fully understand them after this, but hopefully you'll get a little bit of an idea. So transducers, they're a certain type of function, and they're functions where you can describe a transition using a step. So you can go from one state, give a recipe or a set of instructions for how you get to the next state. So if you can't describe the function in that way, it won't be a transducer. What's special about transducers is they're agnostic to both the input and the output states, if you like. They're essentially just describing the step in the middle, and they don't care where they get the input from, and they don't care where the output goes to, which turns out to be very useful. We'll come back to that one. And at sort of a high level, you can describe them as composable transformations. You're transforming one thing into another thing in a step-by-step process. Okay, let's dive into some examples because it's always difficult to understand things just in the abstract. So this is some pretty basic Clojure code where we've got a high-level function filter. It takes a function odd that is true or false, and you pass in a collection, in this case a vector of 5 numbers, and that outputs the filtered collection. So if you've seen Clojure before or any other Lisp, hopefully this looks pretty familiar. So what about this is a transducer? Well, nothing yet, but if we change the arity, and instead of passing in both the collection and the function to filter, and we just pass in the function, then what Clojure is building is a transducer. So it's a recipe for what you do. In this case, you're filtering odd numbers out of whatever gets passed in. So why is that interesting? It's because what happens if instead of passing in a sequence like we've done here, that we pass in a channel or a queue or something where you're just getting one number at a time, because we're describing as a recipe or a set of instructions what you do on each step, we've taken away that connection, the tangling up that happens when you're taking both the recipe and the ingredients, if you like, and you're actually using them to bake the cake. I apologize for my metaphors, but so what we're saying is let's not bake the whole cake, let's just keep the recipe separate. Like recipes are so powerful because I can share them with people, and it doesn't matter where you get your tomatoes from or exactly what your oven looks like, right? The important thing is that you know what to do. Hopefully that makes sense. Okay, here's another example, map inc. That's also a transducer, but in this case, that's mapping increment across whatever you pass in. Again, it can be a channel, it can be a collection, or whatever. And then I said before that they compose really nicely together. So you can use the comp function in Clojure and just place them together. And what that will do is build a combined instruction or a combined recipe that first filters and then maps increment. And like I said, Rich Hickey has explained how these work, and he actually goes into the underlying implementation details, which I've kept this at a much higher level. So if this sounds interesting, and I think it really is interesting, take a look at these two YouTube videos, well worth your time. Okay, so why do we use transducers in our architecture? Why are procs transducers? First and foremost, it makes them composable. It gives us this really nice abstraction where we can say, given this set of inputs, here's how I do that processing, and here's an output. And that's a really nice way to build things. And because they can compose together so nicely, as you saw on the previous slide, it means we can combine them in a multitude of ways, which turns out to be a great building block for your architecture. Another powerful thing is they're agnostic. What I mean by that is they're agnostic to the input and the output, which makes them incredibly flexible and really good for testing. Because in production, originally we had Kafka, so obviously that's this advanced queuing system that's sending you each message one at a time. But when we were testing, we could just say, here's a sequence of messages that's just a vector. And the transducers, they don't care where that's coming from. And what that meant was they didn't care whether it was coming from Kafka or whether it's coming from, as it does now, Foundation DB. It's just completely, they're agnostic to that. So that's incredibly powerful. And then last but not least, they're fast, they're performant, and that's because the way they're implemented, it's eager, not lazy, and that they don't build intermediate state as they're going. So even if you've got a composed version that has, let's say, 5 steps, they will run that on one version of the data that they're passing over. And when you're building a bank, you want it to be fast. So, okay, let's look at an example proc then. So this is one for making a deposit. It has an ID, so this is a map in Clojure. And the ID is basically its name, so it's make deposit proc. And it has a map of messages. So it takes certain messages in. It says, I know how to deal with that kind of message. And when I do, I'm going to output this message or set of messages. In this case, each one only outputs one message, but it could output several. So it's like I take in this message, I output this message. And what's good about this is it's very data-oriented. I know there's going to be a talk later about data-oriented, but obviously it's very declarative. It's not code, it's just data, and that makes it really easy to reason about. So when you're looking at this code, you can understand really quickly, okay, here's what's going to come in, here's what's going to come out. And the constructor is X form is what you call, or XF is what you call a transducer. So let's zoom in on that one. So let's not look at flat map, let's just, what's happening here is we're taking a message, so that's the unit that we're passing over. That's the unit that we care about, and we don't care where that message has come from, like I said. And all we're saying is we're going to look at the message type in the message, and if it's one of these ones that we know how to deal with, we're going to dispatch to the business logic that deals with that code. And it keeps it nice and simple, it makes it very powerful, and like I said before, makes testing a breeze. Cool. So we're whizzing through this. Let me exit that one and show you the sandbox. So this is our website, griffin.sh, and one of the cool things that you can do now, since we launched it just a couple of weeks ago, is use our sandbox. So what that is something where, as a developer, you can just sign up and give your name, your email, and create an account, and then you're off and in our sandbox, and you can start writing code against the API or using our UI, which is what I'm going to show you later. So why would that be interesting to do? Well, perhaps you're working on a side project and you want a more realistic API to try your code against. Maybe you're fed up of just doing some Twitter API or I've seen one where there's like a beer collection from, I think it's Brewdog, where you can sort of see all the beer bottles and create a web app or whatever. But with this, you can actually play around with a real production API. We have good documentation for getting started with it, how you set up your API keys, the HTTP headers, etc., how you can onboard customers, how you can do standard banking things like create bank accounts, make a payment, etc., etc. So that feels kind of cool that we have that possibility that you can use that, but what does it actually look like when you're in? So this is what the Sandbox UI looks like. And there are two main sections, one for managing your customers and one for managing banking, payments, and bank accounts. So let me just show you quickly, because here's one I prepared earlier. So this is running on my local machine, so I can show you the debugging, which we're going to get to hopefully quite soon. But normally this will be, you'll be connecting to our platform, obviously, that's running on griffin.sh. Okay, so we've onboarded a customer. What that means in banking talk is that we are doing checks on that customer to make sure that they're not going to commit fraud. Because don't forget, our customers are fintechs or bigger companies that are wanting to offer financial products. So they need to make sure that the companies that they're, or the customers or individuals that they're doing business with aren't going to cause any problems for money laundering or fraud. So we run automatic checks that make sure that that all works well. And then once you've onboarded a customer and they've got an account, you can do fund transfers and send money between accounts. Okay, enough talk about the system. Let's dive into some actual code. So let's hop over to Visual Studio Code and let me explain what you're looking at here. Maybe I zoom in a little bit. Okay, yeah, that should be big enough. Okay, so what I want to show you is this window on the right here, which is called Portal. So Portal it's a tool for improving your debugging. And how it does that, let me show you instead of talking. So to fire that up, you require the Portal API as Portal, you define and you open. And in this case, I'm in Visual Studio Code, so I've opened the version that actually launches within the editor. And then all we need to do is to connect Portal to Clojure via this add tap, which is a built-in command in Clojure. So that adds, this function will be called with anything sent via tap chevron. So what this is doing is connecting Portal to Clojure. And then if we go to some code here, okay, so this is deep in the proc part of our code base. And here's an example transducer. You remember I said if it's called xform or xf, that means it's a transducer. So that we won't look at exactly how this is working, but the important thing here is we've done the comp, just like I showed you before. So this is a transducer, this is a transducer. Each step here is a transducer, and what it returns is a combined transducer. And one step is about tapping out some messages. So what we're going to do is we're going to go in here and do some live coding and hope this works. We're going to tap out hello world. And let's execute this in the REPL. Nice, and then fingers crossed, if everything's worked well with my local dev setup, it should appear here once we've done a refresh of a page. Let's have a look if that works. It's always exciting with live demos. Now, it doesn't seem to be working, so that's interesting. Let's see if we can figure out why that is. Run that one and that one again into the REPL. Might need to restart. I should have tested this just before I came live, of course. Interesting. This is always what happens when you do live demos. So let's close Portal and let's see if we can get it running again. Okay, so that seems to be working now, hopefully. Move that across to the right. I'm not sure why it lost connection there, but yeah, 251 hello worlds. Let's clear that and let's just double check. Is that working now? Fingers crossed, otherwise the rest of the demo will be very short. Yes, great. Nice, we're back in business. That was exciting. Okay, so back to where we were in the code. So why is it useful to use tap and Portal? That's what I want you to understand here. Why wouldn't I just do a print line or a log? And the reason is when you do print line or log, what's happening is you're sending strings essentially to a file normally. And strings can be useful, and if you pretty print them, it's great. But in Clojure, we have the power of A, a REPL, and B, that we have these data literals, data-oriented, coming back to that. So what that means is if we get rid of hello world, and instead we send the message that's being passed through, let's execute that, send it to the REPL. Let's clear that one. Let's go back and refresh. Fingers crossed. Yes, great. So these are all the messages that the system has created to render that page. And what's happening is as we're scrolling down, what we're doing is we're going backwards in time. The way that Portal works is it appends from the bottom, if you like. So the very bottom message here is the very first message that's sent to start rendering that screen. So this first message, let's look at the message type. It's a session authenticated message. So it's about security and checking that we have the rights to access that page, right? So, but here's the cool thing. Because this is data, what this is showing us is we have, let me go all the way back to the top, there are a lot of messages here. So we have 51 messages, and those are in a sequence. You can see the normal brackets. These more curly brackets show us that we've got a map. So we've got a sequence of maps. And then we can see this map has 7 key value pairs. This one has 16. And because Portal understands that this is data and not just strings, it can have context-aware ways of viewing this data. So we can switch it from the inspector view to a tree view. So that enables us to go much deeper into the code. So if there's nested data structures, this is going to automatically open all of those up and let us go very deep into the data. That's cool. What else can we do? If we go back to the inspector, I selected the wrong thing here. Yep, top level. So that's the other cool thing. You can choose to change the view just for specific parts. So at the top level, I've said inspector view, but let's say I just wanted to make this one look like, say, a table. I can do that, but you'll see the rest still have the old inspector view, which is nice. And you can do other things. It knows that this is an instance or a timestamp. So here we can say, show me that as a date time, or show me that as relative time, which I find really useful. So we know that that happened 2 minutes ago. When you're debugging, having that ability to see that rather than a timestamp that you need to constantly be thinking, well, when was that? That can be really powerful and really useful. And when you have nested, you can just hit space and expand down into your nested data structures and just explore them that way if you don't want to view them as a tree. So it just gives you this really powerful way of moving around the data that you're exploring as you're working with the REPL. You can also do filtering. So what was the name of that? It was something like session authenticated, was that? So if we do a filter that says session, let me zoom out a bit now. Oh, okay, I see what's happened. So what happens is where you're selected, that's where it does the filtering. So I thought I was filtering on the main list, but actually I think I was just filtering there. So if I now go to the main list and start typing, let's see if that works any better. Yeah, you see now it's selecting and filtering. So again, when you have lots of messages like we do, if there's only one particular type of message that you're interested in, being able to quickly filter down to that feels like a bit of a superpower. Okay, so we've looked at messages. Let's go back and see what else we can figure out about this by also looking at, let's say, so we've got the message, and let's add the proc as well. So proc. And then we're using both of the arguments that are being passed in. And let's see what that looks like when we evaluate it. Clear out this old one and head back over to here and refresh. Okay, page is refreshed. Okay, so all those messages that bounce around the system. And let's switch this view. Let's switch the top one down to a tree. So then we're seeing both the messages and the proc. So the proc tells us which is the processing unit or the processor that's dealing with that message, and then the message, of course, has all the detail about the message itself. So again, super useful. And is there anything we can, if we switch back to the, sorry, I'm trying to do coding remotely from a screen that's quite a long way away, so it's a little bit tricky to see. But let's expand one of these. what's interesting to pull out of this is probably the message type. Yeah, let's pull the message type. So if we copy that one, so as well as pulling the message out to the top level, what we're going to do is pull out, if I can type message dash type, and then we'll grab that one out of the message. Nice. And was there something similar that we could grab out of the proc? What's useful here? Probably the ID, which is essentially the name of the proc. And that way, if we pull these out to the top level in our map here, it's going to help us to know. So we'll call that proc ID, paste that, grab that from the proc. Let's execute that. Clear our portal again. Go back and do a refresh. Okay, and now what we'll do is we'll switch this to a table view. And the reason it knows that we can do a table view there is because what Portal is doing is detecting that it's a sequence of maps, and it knows that if it's a sequence of maps, then I can easily turn that into a table where each row is each entry in the sequence, as it were. So now we've got message type, we've got proc, and we've got proc ID. Nice. So imagine if you're working on this system, just being able to quickly whiz around, see the different messages, see a message that you're not expecting to turn up in a particular order. It's really powerful. And we've only just sort of started scratching the surface with Portal, because it has some features where you can write your own views. So these are the default views in Portal, but you can actually write your own and do some really clever things with visualization and showing nodes and edges in a graph. And one of the things I'm excited by is we make quite a lot of use of finite state machines in some of our procs for managing state and transitioning between different states. And I'm sort of imagining what would that look like if we could visualize each state and the different transitions in a really nice way. When you're debugging the code, suddenly you've got this new way of looking and thinking about what you're seeing in a way that just working with a REPL or just working with logs doesn't quite give you that same level of power. I just want to show one other cool feature. You can select, let's find two messages that are similar. You can actually select multiple entries and do a diff. Let's select this one and this one. So I've command selected, and you have all these commands built into Portal, including a load of core functions. So you can do sort of basic programming here, but what we're going to do is do a diff between those two. These two were so different that maybe the diff isn't that useful. But sometimes you're going to be getting bits of data back that are similar, but you can't quite see where is that different. I was expecting those to be the same, and you just grab them both, you do the diff command, and then it immediately jumps out, it's different here. And again, it speeds you up. It's about being faster with your debugging. It's about getting to see your data in a clearer way, and it's about getting things solved quicker. Cool, I think that was it in terms of the demo. Was there anything? I can't think there was anything else I wanted to show. Let's hop back to the presentation. Okay, we did the Sandbox demo, did the tap on Portal demo, which we got working. Okay, what have we learned? So, even if you haven't fully understood transducers, hopefully you've understood something about how flexible and powerful they are, and a little bit about why we chose to make them such a core part of our architecture. And again, it's the fact that they ignore, or not ignore, they don't care about, they're just the recipe, they're just that part, and they don't care about the ingredients or which oven, right? Remember that metaphor? Which makes them incredibly powerful. And then tap and Portal. We didn't talk much about tap. Let me just say what tap is. So tap is this built-in function that's been in Clojure, I think, since 1.10. And the basic idea is to output data rather than just text, so that you can create different visual ways of working with it, such as Portal. And there's been some other things like Rebel and some other tools that you can use that really enable you to sort of dash around your data in a much more powerful way. than just with a REPL and or outputting text. And that was it. Thank you very much.
Thank you very much, James. I will run on stage. Thank you very much, James.
Pleasure to be here again. Thank you.
Yes, you're welcome.
Shall I just unplug?
No, leave it in. Leave it in. No, please stay.
Oh, please
I'll have
stay.
some. Yeah, I have some tough questions for you.
Oh,
Or
fire away.
joking. No, first, brave that you did live coding.
Yeah,
And also when
it almost totally failed.
Yeah, and then it doesn't work. What do I do? The stress is just immense. Slides, will they be shared afterwards?
Can do.
Yeah?
Yeah.
Great. Also, I want to push a bit for your presentation. The last time you were here, you did banking as a service. You can see it in the channel if you just check around in the Func Prog Sweden YouTube channel. We will also I saw that you had some links to the
The transducer talk.
transducer talks.
They were more just strings to search for, but maybe we could post the links.
We'll
for
post the
people.
links in below the vid so people can see them if
Yeah.
they want to. Also, I got one question. One question. Why did you shift from Kafka?
I thought somebody might ask that.
Yeah, I would. If no one asked, I would.
Yeah. It's a long story, but
Yeah?
the short way of answering it is basically non-functional requirements.
Oh.
So the way that we architected the system is a lot of procs with a lot of messages, which means that you're sending these messages all the time, and it basically wasn't fast enough. So we're not saying Kafka's slow. It was just the way we were using it meant too many network hops. Exactly. And what we didn't want to do was to I was talking about these procs being a great building block. What we didn't want to do is sacrifice that and start saying, well, let's just make bigger and bigger procs that do more and more and become more and more monolithic. That isn't a good way out. So we looked into different options, and it was our CTO, Alan, that discovered that Foundation DB had a lot of the same sort of scaling and reliability properties, which you need as a bank, obviously, but it gave us a lot when it came to performance, and it also is better around transactions. So it's actually ACID compliant as a database, and what that means is we can do a number of these message hops within a single transaction. So it's basically within memory, so it's not going over the network, and then you transact the entire thing. So in terms of performance, it's night and day with what we have with Kafka.
Yes. And now you're not just Griffin is not just bank as a service. It's actually also a bank. Does it mean that anyone can come to you and just say that I want to use it? Or I guess there are some vetting done, or?
There's definitely, so the onboarding that I showed.
I'm just very curious myself.
The onboarding that I showed,
yes,
that was from a customer perspective. So that's our customers onboarding their customers. So we consider those customers our nested customers, almost like a Russian doll of that's how we describe it. But of course, we have to onboard our customers, and we have to do the same kind of due diligence, maybe even more strict, or depending on what their regulations are. But as a bank, you're very strongly regulated, and it's very important that, companies can't do business with you if they shouldn't be doing it.
Exactly.
So obviously that's deep, what's called IDMV, or identification and verification checks on the owners of those companies, and looking into their backgrounds, and many different checks that we do. So it's not a commercial bank. It's not a high street bank. It's not like HSBC or Barclays. It's a bank for other companies to build their platforms on top of.
Thank you very much, and very interesting. Thank you very much. There's no more questions. Then again, thank you, James.
Thank you.